Yo, this is what we're doing today. We are making a detection system for like a set piece. Gotta get from one side to the other. It blinks as well, so there's like a random chance that this eye will blink, and if it catches you, then it sticks to you, like so. Let us know any other mechanics or set pieces that you are looking at trying to make, and we'll see what we can do. Special thanks to our YouTube member Phoenix Studios and Imagine Bravery. If you guys are gold members, then you get access to our project files as well, and this will be there too. So thanks for watching, everyone, and I hope you have a great day. Any questions, then leave them below. So first thing we're going to do is we're going to go to Fab, and we're going to get this Ophian Angel model. Just going to click Add to Project. And then it's going to download. Now it says it comes with an animation, but it doesn't, so we're going to make our own later on. But next, while that's downloading, let's make a blueprint class. So right click, blueprint class, we'll get an actor. This will be BP I detection. I don't know, whatever you want to call it, like set piece or just, yeah, whatever you want to call it really. Or BPIs. All right, open that up, and then inside here we're going to add a skeletal mesh, and that will be of the Ophian Angel, and then we just need to rotate that by 90 degrees. So 90. Compile and save that. And now we can add that to our level and set that up. And there's our scary looking eye blueprint, which looks pretty cool. So now back in BPI, so then we're going to add to the skeletal mesh, so make sure you set skeletal mesh, and then we're going to add a cone, basic shapes cone, and that's going to be brought out, and then we're going to rotate it. And you probably want it to be on the scale 3, 5, and 8. Okay, and this will be our enemy's like sight line. So just line it up properly. There we go. And then what we can do is in the cones overlap events, we're going to make this one no collision. And then we're going to duplicate that cone and put it inside it. And this will be the inner cone. And this is the one that we're really bothered about, this inner cone. And then the size for this will be 0.8, 0.8 and 1, 0.8, 0.8 and 1. Okay, and this inner cone is going to be hidden in game, false, and visible, also false. And the reason for that is that when we overlap, we want it to be more inside the cone, whereas like our capsule is going to overlap first. We're going to give the player a little bit of like grace. Right, on the inner cone, we need some collisions. So a custom collision, it needs to be query only and world static, and then everything except pawn, which needs to be overlap. That's it. Now, if we right click our inner cone, we can add an event on component begin overlap, and when other actor is equal to get player character and a branch, then we can say, yeah, we've interacted. So we can promote this to a variable, this other actor. So just drag off and promote. to get a branch, we can drag off the red one and press B. And then selecting the cone again, right click it, add an event on component end overlap. We're going to check if other actor is equal to the other actor that we've already saved, get branch. And if it is, then we're going to set other actor to false, so we haven't detected anything. And we can test all this by doing print string here, doing detected, and one here for lost detected. And now, if I right click and say play from here, when we overlap with detected, lost detected, so that we know all of this is working. Okay, but let's make this a bit more fancy than white. So we're going to right click, get material. This will be M detection cone. Open this up, and we want a constant 4 vector. Constant 4 vector. There we go. You can make this whatever color you want. I'm going to make it red. Select M detection cone, and this will be surface. Blend mode will be translucent. And then we can put the constant into base, and the opacity we can make like 0.5. 0.5. Then back in BPI, we can select inner cone, and we can change our element 0 for both of these. And then in our game, this looks much more like we're being detected. Yeah. Beautiful. So now in BPI, we want a begin play node. So on event begin play. And on event begin play, we're going to get the actor rotation and promote this to a variable. This will be the starting rotation. And then we're going to right click and create a new custom event. And this will be our rotate event. And we're just going to call that from begin play. So rotate. We're going to get a timeline. So we're going to add timeline. And we're going to open that up. And this is where you set how long you want it to go from like point A to point B. So I'm going to go 20 seconds, add a track with a float track, add a key by right clicking, making the first and the second timer 0. And then right click again, add another key. This time will be 10 and the value will be 1. So it's going to go from 0 to 1 in 10 seconds, 1 being like the other side. And then I'm going to add another curve, and at time 20, go back to 0. So it's going to move from one side to the other side. We'll get our event graph. And from this new track, we're going to alert rotator, which means we're just going to move our character from one side to the other. And then we're going to set actor rotation. But we haven't told it how far to move yet, so we need to do that. But we've got our starting rotation. And what we're going to do is combine rotators. And plug this into A. Now we'll have 60 on this side. And then I'm going to do duplicate. So I'm going to select both of these, do a duplicate, and I'll have minus 60 on the other side. And we'll plug that into B. So now in third person, if I come up to the top and press play, here we are, and it's scanning 60 degrees from its left and 60 degrees from its right on its starting point. It goes back. But you'll notice that it stops there. So what we need to do is come back to our BPI, come back to this timeline, and select this loop function in this timeline. And now it will go from one side to the other, back to the other side, and then restart itself again. If I'd have done from this side to this side, from 0 to 20 in the length, 0 to 1, then it would automatically snap back to this side when it starts to loop. So we just want it to smoothly transition from one side to another. Right, that's that bit done. So we've got the basics all set up, but now you'll notice that if create a little course here, and this side as well, so we'll just move this around. So if I overlap here, it detects me and it loses detection. So we've got to detect here. I'll go behind here. But as soon as it overlaps me here, it's detected me. So we want to make sure that we have line of sight when we actually see. So what we're going to do is we're going to create a custom event. We're going to call this check line of sight. And quite simply, we are going to do a line trace for objects. And the start location will be get at location. So our I location. And our end location will be our other actor. Yeah, actor location. And then this object types, we're going to drag off and make an array. We're going to add a few to that. So world static, world dynamic, and pawn. So world static and world dynamic are the blocks in our world, and pawn is our character. We can also add destructible as well. So if there's something you want to destroy in the level, it will block it for the time being. And we can draw a debug for duration. So next we want a return value to say that we hit something. And then from there, we're going to get this out, hit and break it. And then we're going to check that the hit actor is equal to our get player character. And another branch here. From this false, we're going to get a print string. Because if it's not equal, then we know it's a wall. And if it is equal, then we can print string player. And to trigger this, whenever we overlap something, so when we detect something, we're going to now call our line trace, check line of sight. So now in third person, if we play, you'll see that I'm doing a line of sight check just here. And then if I'm behind this wall, so we'll just wait for it to come back, it prints wall. But you'll notice that I can do this. I can hit the wall, but then stay inside the circle. So we don't want that to happen. We want it to be check in. Once it hits the wall, we want it to check multiple times if something is still being hit. So to do that, we're going to create another custom event. Add this custom event. This will be the still line trace loop. And then from here, we're going to get a set timer by event. This return value needs to be promoted to a variable. This is the line of sight timer. And this red event line needs to go into check line of sight, the red node at the top. So red to red. We need to make sure that this is looping, and then we'll loop it every 1 second. So now if it hits the wall, we're going to trigger this custom loop. So the line trace loop. So now we can play from our game, and we can see that it's detected the wall. Now it's detected me, so we know that it's detected me, and it's running the trace, and then it starts tracing for the wall. But the problem is when we tab out of this, we're going to get all of these errors, because once the cone stops overlapping with us, we say that this other actor that we're looking for the location of isn't valid anymore. Okay, so what we need to do is set up a fallback so that it continues to trace against the wall, and then as soon as we are out of the wall, it can find us again. So for that, pretty simple. We're going to get this other actor, right click it and convert it to validated get. And if it is valid, then this actor location, so other actor get actor location, we're just going to promote it to a variable. And if it is valid, put it in here. And then if it's not valid, we're going to duplicate it and set it to 0, 0. And then this end location. So we got two sets and both of them go into line trace. This end location, we're going to drag off and get a select. And then if this other actor, we can drag off here and get is valid and get the F function one. And we put this into the bottom of the select. And then we drag it out because this is looking pretty messy. And then if the other actor is valid, we're just going to get the new location variable that was set and plug that into true. If it is not valid, so if it's false, then we want to do get actor rotation, get forward vector, multiply, and then add. And we add this to the get actor location. So get actor location goes into the top of the add, and the bottom of the multiply goes into the add. And then this goes into the false. On the multiply, we're going to right click it, convert it to a single precision float, and we can put a value in there like 2000. And what this is going to do is, if we don't have a valid actor, it's going to trace to the wall multiple times. So I'll show you. So now it's tracing to the wall. Don't have a valid actor anymore, but it's still on the wall. We just need to keep checking that. And then it traces to the player that it's in front of. Okay. Now what we want to do is, when we have detected the player, is we are going to stop our timeline. So we have a timeline component here, get timeline, and we'll say stop. I'll freeze our timeline, and then we can do get actor rotation. We can get the other actor and get actor location. And apologies, this isn't get actor rotation, this is get actor location. Get actor location. And then we can do find look at rotation. Find look at rotation. And then set actor rotation. And this will snap straight to our target. So if we are just on the edge of our cone, so like here, and now I run back and straight away snap to. Okay. But then what we want to do is keep it rotating to the player. So we're going to create a new custom event. And this one will be rotate to player. And this is going to be set timer by event again, because we want to keep this loop in. 0.01 seconds. Promote this return value to a variable. This will be rotate to player. for rotate to player loop. This new var here that we've not named is our detected actors location. And then click loop in from event. We're going to make a new custom event. This will be rotate to player loop. Rotate to player looping. And we are going to go get these nodes at the top, just grab all of them, Control C, and paste them all at the bottom. So, and then we're going to call the line trace function by line trace loop. Not the line trace loop, sorry, we're going to call check line of sight. So after set to rotate, I'm going to check line of sight. There we go. And now we should, if we go back to BPI, we can then call the rotate to player function at the top. Rotate to player, power that, play from here. And now if I run into here, there we go. Now it knows where we're looking. And when we overlap, it knows. And if I hide here, right now it's not letting go. So we need to make sure that it lets go as well, because we get all these problems here because it's stopped overlapping. So this rotate to player loop, we need to stop it. So when we hit a wall here, we are going to then call this rotate to player loop and clear and invalidate timer by handle, because we've hit a wall, so therefore we're stopping the player. Then we call the line trace loop, and then we want to call rotate again, which is just the original, not rotate to player, just this rotate down here. What this should do is we've been detected, now we hit a wall, and it goes back to what it was doing. But you'll notice that the line trace that's tracing for the wall is still running, so we need to stop that line trace for the wall as well. And the way to do that is on the first false, when we haven't hit any values. So we've stopped hitting the wall, we've hit thin air, then we want to get our line of sight timer and clear and invalidate it, put this on the false, and then our other actor set this to also be false. So we can test this again. Here we are hiding by a wall, and it's tracing, then stopping. It's not tracing anymore because it knows that we've not detected the player. And here we are with player detection. So now if I hide inside this cone, it detects us, we're running around, it keeps its eye on us and rotates towards us. Go behind this wall and it resets to start looking somewhere else as well. And then if I just stand out in the middle of the wall, it knows straight away that this is. Okay, so let's make this a little bit more interesting. We're going to create a blink function. So let's do a custom event. Our custom event, and this will be blink. And now we need to get set timer by event. And this one we want not to be looping. this is more like a delay, but we want the time here to be random floating range between 1 second and 5 seconds. We're going to drag off event and get another custom event. And this will be start blinking, blonking. What's blonking? Blinking. And then simply we're going to get the cone, set its visibility, and we're going to set that to be false. Get the inner cone and set collision enabled so that we don't overlap it, so no collision. For now, we're just going to have a delay, but in a minute that's going to be an animation. So delay of 2 seconds. And then we're going to grab both of these nodes, duplicate them, and reset them. So new visibility, query only, and then we're going to call blink again. And that's just going to run in a loop and randomize itself every time. Like I say, you could do a delay, but I just prefer to do it this way. It's a bit more controlled. Begin play as well to start the process. So we find begin play, and then we can call blink, start blinking. Oh, blink. We'll call blink. From here. There we go, off, and then turns it back on 2 seconds later. And if we're standing in it when it's off, then it won't do anything until it turns on. So you probably end up closing that down and coming across an error. And what we just need to do is on this rotate loop is just make sure that the other actor is valid that we're searching for, and if it's not, then we're going to get our rotate to player loop and clear and invalidate it. This should make it better and work. And now it'll still blink, but it will rotate back if we blink. But we might want to stop it blinking when we catch our player. So here's its blink, and then straight away we caught. So we get that, and then we'll check this other error that we've got. And again, we're just going to convert this to validate get. If it's valid, we set the actor to be valid. But if we have caught the player and it's valid, we don't want to still blink. So I'm going to promote this blink set timer event to a variable. This will be the blink timer. And then if we've been caught, we are going to clear and invalidate the timer after we set the initial rotation and before we call rotate to player. Like so. And on when we hit a wall, we're going to enable the blink function again. And this should be everything we need. And then do a blink. And then if we stand in there, once it blink turns off, then it's fine. And then when we run across, we're all gravy there too. And we get no error messages. Now what we need to do to animate this eye is we need to get this skeleton and raise it up. And then right click, create a level sequence, open the level sequence. And we're going to add actor to track and we're going to make sure it's this skeleton here. This animation that we've got, we're going to do nothing with because we're going to make our own. So we're going to right click on the skeleton, bake that to the control rig, and press create. And then we're going to get this FK skeleton, and we're going to find some bones. And the ones that we want to find are bone 01. We're going to select on this little squiggle line, select everything that's in there and delete it, and then save. And then we're going to grab the little rotate tool, rotate the eye to the left, and press the plus. Go to 30 seconds, rotate it all the way to the right, and it'll update automatically, so we don't need to do anything. So then back to 60, we'll go to the middle, 90 to the left, 120 all the way to the right, and then 150 all the way to the left. And then when we scrub back, we can see this eye moving around, do some slow stuff, and it starts on the left and ends on the left. And then right at the top, we're going to right click off an angel and bake animation sequence, and select OK, export to sequence. And then we're going to get bone 0203 and test which one it is, and we'll see that's this lower lid. And the bone 0111, that's the top lid of the eye. So we're going to select both of these by pressing Control, selecting the little squiggle line, getting both of them, and deleting the curves on both of them. And then now, what we can do is we'll set a key in both, and we'll go to 75 seconds on our bottom lid, which is 00203, lift it about halfway, and then drop it down at 150. And then on our top lid, which is 001011, bring that down so that we've closed the eye, and bring it all the way up to say that we've opened the eye. Save that, right click it, bake it to animation sequence, select OK, export to anim sequence, and then back inside our blueprint, the BPI, go to the event graph, go to the viewport, select skeletal mesh, and into play will be our first one. See it's rotating around, going a bit crazy. And then in the event graph, we can do the skeletal mesh, play animation, and select the second one. So easiest way is to go to Fab, the angel skeletal meshes, find it, and then press this little button here. Set a delay of about 4 seconds, and then right at the end, set a new skeletal mesh and animation node, and revert it back to the old blinky eye. And now, if we close down the level sequence, get rid of this skeletal mesh in the level, and then press simulate. You can see the eye is moving around. There's our blink, and it's back. Like so. And therefore we've set up an animation and a full-on blueprint. If you wanted like attacks to happen and stuff, then you could just spawn an actor over here, or if you want the game to end, then create a widget, all that sort of stuff. Just get it ready to be here and set it up. And then what could happen is once you add the animations, it sends everything funky. So it'll rotate 90 degrees, and it's just a bit weird. I don't quite understand why it does it. But if you do from find lookout rotation, combine rotators, and add 90 degrees, it'll set the actor's rotation properly. Then yeah, combine rotators. So I'll show you what it does without it. And just does that. Just puts it 90 degrees over to the other side. I think it's got something to do with the animation and the skeleton, but this is the fix. You just rotate it by 90 degrees. If you're using a different static mesh or skeleton, you may not need to even do that. It's purely just for this one, I think. But that makes it work as intended.